Okay, so this is 5.8 practice. Before we start, we're going to actually warm up by multiplying a bunch of these binomials. So take a minute, pause the video, and just go through 1 through 4 and make sure you're good with multiplying binomials. Okay, so when you do that, you should get these answers here. So take a minute, look at your work, correct it if you need to. And then I kind of want to talk about kind of where we're going from here. So today we're going to kind of like reverse double distribute. So we're going to go backwards from double distributing. We're going to start with something like this, and we're going to come up with factors or products of our two binomials as a product of a trinomial. Okay, so we're kind of going to go from here to here. And so what we need to do that is notice patterns within my numbers. So I talked about this on the very first day we talked about polynomials, but standard form for polynomials are in the form of ax squared plus bx plus c. And so a is the coefficient, a and b are coefficients. And c is the constant of, so this is just like the number, whatever it is. And so a is the coefficient for x squared and b is the coefficient for x. So I really want to talk about these b and c and what they have in common. Okay, so if we look at this trinomial here, my a is 1. That's the coefficient on that number. My b is 11. And my c, or my constant, is 30. Okay, so now I want to ask you, what do 5 and 6 have to do with 11 and 30? So what do positive 5 and positive 6 have to do with 11 and 30? So you might notice if I add 5 and 6 together, I get 11. And if I multiply 5 and 6 together, I get 30. So that's really the pattern. B is the addition of these two numbers, and C is the multiplication of these two numbers. So that pattern is really important. If I look here, my A is 1, my B is positive 1 again, and my C is negative 30. So again, if I look at negative 5 and 6, what do those have to do with 1 and 30? Well, if you notice, if I add negative 5 and 6 together, I get 1. And if I multiply them, I get negative 30. So again, that pattern holds true. In this polynomial, A is 1, B is negative 1, and C is negative 30. So if I look here, I have a positive 5 and a negative 6. If I add 5 minus 6, I get negative 1. If I multiply them, I get negative 30. So again, this pattern still holds true. Finally, if I check it here, B is negative 11 and C is positive 30. If I have a negative 5 and a negative 6, those will add to be negative 11. And if I have a negative 5 times a negative 6, I add them to be positive 30. So that's kind of the battle. You have to look at what you have in this, what your B and C values are, and think of numbers that will add to be your B value and multiply to be your C value. So we're going to kind of practice that first. So this is called the sum and product game, or when you play this game, you'll use it every time you factor an expression. So it says fill in the missing factors for each product so that the sum of the factors is equal to the corresponding number. So for example, I want two numbers that have a product of 8, but when I add them together, they equal 9. So this is what I am going to kind of do. I'm going to kind of think about what are my factors of 8. So 8, I can do 4 and 2, or I can do 8 and 1. So this is where your number sense is going to kind of come into play. So 4 and 2, I'm going to check. They don't add to be 9. But 8 and 1 add to be 9. So this pair won't work. Only this pair will. So the first factor could be 8 and the second factor could be 1. 8 times 1 is 8 and 8 plus 1 is 9. Okay, again, if I try with 18, I'm looking for factors of 18 that add to be 9. So my factors of 18 are 18 and 1, 9 and 2, and then 3 and 6. So which pair of factors adds to be 9? Not 18 and 1, not 9 and 2, but 3 and 6 do. So that's kind of the pattern you'll use. You're going to first list the factors of the numbers, that they should be the product, and then you're going to, okay, which pair gets me a sum of this number? And so you'll do that in this row, and then you'll do that in this row. Okay? This is important because it gets your thinking ready for factoring. So pause the video, do that, and then unpause it, and we'll keep going. Okay. So now we're going to get into like the meat and potatoes of this. So factoring quadratic trinomials. So we're going to factor polynomials that look like this, but we're only going to factor them when this number is 1. So an expression ax squared plus bx plus c, where a and b and c are constants, and a does not equal 0, is called a quadratic trinomial. It has 3 terms, which are an x squared term, an x, and a constant. So in order to factor trinomials, we are looking for a pair of numbers that satisfy 2 requirements at the same time. They must have a product equal to c, which is this number, and they must have a sum equal to b, which is that number. Use examples below to help clarify this technique. So the first thing we're going to factor is this polynomial here. So I'm looking for 2 binomials that when I multiply them together, I get that. So the first thing I'm going to do is identify what my a and b terms are, a, b, and c. So again, a is always going to be equal to 1 in these examples. So that coefficient here is 1. My b is 6, and my c is 8. So again, I'm looking for factors of 8 that add to be 6. So you're going to set up your parentheses first. So to get, if I were to go to multiply these, I need to get x squared first. So in order to get x squared, I know that this has to be x and this has to be x, because x times x would give me x squared if I distributed them. So that should be x always. And I'll zoom out a little bit. Then we did this a part, a, b, and c part. I'm going to list the factors of the c term. So my factors of 8 are 8 and 1 and 4 and 2. So then you ask yourself, what 2 numbers multiply to get c and add to get b? So which pair of these add to get b? So my b is 6. Which pair adds to be 6? Well, this pair is 6. So I know 4 and 2 is the pair I want to use. And so these numbers will become the second terms in each binomial. Be careful to keep the appropriate sign. So these are both positive, which means I'm going to have a positive 4 in one and a positive 4 in one and a positive 2 in the other. Okay? And so that is my factored product. I know that these 2 binomials will multiply to get this. And I can even prove it. And the best part about factoring is you can always check your answer. So I can just go backwards and distribute these. X times x is x squared. X times 2 is 2x. 4 times x is 4x. And 4 times 2 is 8. So if I simplify that, I get x squared. 2 plus 4 is 6. Plus 8, which is exactly what I started with up there. So I know that this is right. So this is my answer. Those are the product of 2 binomials that multiply to be what I started with. So really, factoring is like reverse distribution, and sometimes you'll hear that. You'll hear that being referenced. Okay, so let's do another example. So I'm gonna skip B. I'm not sure why that was there. There's nothing to factor there. So let's try part C. So this is the trinomial. I want a factor, or the polynomial. And so the first thing I'm going to do is I'm going to list out my A, B, and C values. So my A is always 1. That's there. My B is -5. So always take the sign in front of that coefficient. So -5 is my B, and my C is -84. Again, negative. So I want my product to be -84, the C value, and I want my sum to be B, which is -5. So I need to find factors of -84. So I know that when I have to find factors of a negative number, I'm going to have one negative and one positive. When I multiply a negative and a positive, I will end up getting a negative. So what I'm going to do right now is over to the side here, I'm going to list the factors of -84. And if you're unsure, I just start dividing 84 by different numbers to see if I can find them. So 84 divided by 2 is 42. So I have 42 and 2. One has to be negative, one has to be positive. So then I could also have 42 and -2. And so I check. If I add those together, either of those combinations, do I get -5? No. So I'm going to keep going. 84 divided by 3 is 28. So I can have 28 and 3. Or I can have -3 and 28. Those don't add to be 5, so I'm going to keep going. 84 divided by 4 is 21. So I can have 4 and -21, or -4 and +21. Those don't add to be 5, so I'm going to keep going. 84 divided by 5 will be a decimal. 84 divided by 6 is 14. So I have 6 and 14 are factors, and one can be positive, or then I can do one negative. Those will both get a negative product. Those don't add to be 5. I know I'm close because 14 minus 6 is going to be 14 minus 6 is 8. So I know that I'm close. 8 is close to 5. So I'm going to keep going. 84 divided by 7 is 12. Okay. So let's see. 7 and 12 are also factors. I can have a -12 and a +7, or a -7 and a +12. And so this combination, if I do 12 minus 7, I get 5. But that's actually a +5 if I add them together. If I add a -12 and a +7, that's when I get a -5. So this combination is my combination that I want to use. So notice how long that took me. It took me a long time. But that's okay. Sometimes it takes a while. 7 and -12 are the factors that add to be -5. So I have 7 and -12. Those are my two numbers. When I add them together, I get -5. When I multiply them together, I get -84. So now I just have to write my answer. So again, if I want to get, I need two sets of parentheses. If I want to get x squared, both of these need to be x. And if I want to do, so then I can just take, and I'm just going to take these signs. So this is a +7, so one parentheses will have +7. And this will have, this will be a -12, so this will have a -12 in it. You could also write it like this if you wanted to, because the commutative property tells me that these are the same. I just switch them around. And so that is my answer. And I can check my work. I can double distribute to see if that is if that is correct. Okay, so there's another example. And now the practices should be relatively easy, depending on, so you're going to use the same method. So first, for each of these, decide what your A, your B, and your C are. And remember, you want to multiply to be C and add to be B, and then try to find your pairs of numbers that do both of those things. Okay? If you have questions, let me know.